Now let's find the area of the region bounded by the curves f of x equals e to the x and g of x equals e to the minus x, and the lines x equals 0 and x equals ln of 3. As always, we need the graph so that we know which curve is on top. The e to the x curve looks like that. It goes through 1 on the y-axis. And the e to the negative x curve looks like that. And it also goes through 1 on the y-axis. Now we're looking at those curves between x equals 0, which of course is the y-axis, and x equals ln of 3. We don't need to know exactly what numerical value x equals ln of 3 has, although you could use a calculator and find out that it's a little bit over 1. And then the area we're interested in is the area of this region. Oops, I forgot to label my other function, g of x. That one is e to the minus x. Okay, let's set up our area integral. The area will be the definite integral from 0 to the ln of 3 of the upper curve, which is e to the x in this case, minus the lower curve, which is e to the minus x, dx. Antiderivative of e to the x is e to the x. For e to the minus x, we can do a little u substitution. If u is minus x, du will be minus dx. So I'll be putting minus du in for dx. By the way, it's best to do this off to the side rather than putting your u substitution over there, because it interrupts the flow of the antiderivative and integration work. You don't really want stuff between your things that are equal to each other. Anyway, I'm going to be integrating then e to the u du. And this other minus sign can come out front and just cancel the one that was already out front. So, and I need to put in that we're going from 0 to ln of 3. Okay, that step looks good now. So antiderivative for e to the u is e to the u. And we're going from 0 to ln of 3, but those are x values. So let's put in what what u really was, which was negative x. And substituting in then we have e to the ln of 3 plus e to the minus ln of 3 minus e to the 0 plus e to the minus 0. E to the ln of 3 is 3, right? Because the e and the ln cancel each other. Oh, and that should have been a plus up there. Plus here. Now we have to be a little bit careful with this next term. We can't say that the e and the ln cancel each other because there's that minus in between them, and that minus sign gets in the way. What we can do, though, I'm going to go off here to the side, to the left, and remind you of this. We have a rule that says if you have a number times ln of something, that coefficient out front can turn into an exponent on the thing inside the log. So where we have minus ln of 3, that's minus 1 times the ln of 3. That minus 1 can turn into an exponent on the 3. In other words, what we really have is the same thing as ln of 1/3. So let's write it that way in our calculation. E to the ln of 1/3. And the e and the ln will cancel each other out. So we'll have, in our next step, we'll have 3 plus 1/3. Let's finish off each line though. In the parentheses, e to the 0 is 1, e to the minus 0 is also 1. So we have 2 in parentheses, so we're subtracting 2. Combining terms, 3 minus 2 is 1. And 1 plus 1/3 is 4/3. In other words, we have just determined that the area of this shaded region is 4/3.